Yeah. I'll take one more example for your round robin scheduling algorithm, and just I've given time quantum as 2 milliseconds, and you can just see here. First and foremost thing is I'll write the ready queue. Okay. In order to know the order of execution, and this is your running queue. Okay. Whenever they give arrival time, only at that time you can use this ready queue. Okay. Running queue is nothing but your Gantt chart. Okay. At 0 second, you can just see two process has entered ready queue. So I'll just write P1 and P2. Time quantum I am given as what? 2 milliseconds. So now P1 will execute first. How many seconds here? 2 seconds. If it's going to execute 2 seconds, remaining is how much here? 8. After that, P2 will execute. Only 1 second is there. So it's going to execute only for 1 second. That is your 3. Hope you are clear with this. At third second, you can just see new process will arrive into your ready queue. I'll place in the queue. And if your P1 and P2, which came at 0 second, if it is not completed, see here, P2 has completed, but P1 is still there. So I'll place P1. If it is not yet completed, any process not yet completed, after writing the newly arrived process in your ready queue, I need to place the process which is not completed again after that. Hope you are clear up to here. Okay, now what happens is at that second again P3 came, I have entered into ready queue, and P1 not completed, again I have placed. Now P3 has to execute for 2 seconds. If P3 is going to execute for 2 seconds, only 2 seconds is there, it becomes 5. Again P3 also completed, P2 also completed. At 5th second, which process came here? Your P4 came into your ready queue. But P3, any time is there, so fully it is completed, so I will not place your P3 into your ready queue. So next, again, what is the next process in your ready queue is P1. It's going to execute for 2 seconds, so at that time it becomes what? 7. Remaining out of 8, it becomes what? 6. So P1 not yet completed, so again I will place, whenever it is not complete, again I will place in which one? Your ready queue. So next process in your ready queue is which one? Your P4. It has to execute 2 seconds, but only 1 second is there. It is going to execute only 1 second. So if it is going to execute, P4 also completed. P4 is there? No. That's it. P4 I am not going to write. Again, next process to execute is which one here? P1. So P1, if it is going to execute for 2 seconds, it becomes what? 10. So next remaining is what? 4. At 10 second, new process that comes, which one here? P5. New process comes, that is your P5. But P1 not yet completed, still 4 seconds is left out, that's why I will again write P1. Hope you are clear. Next process to execute is which one here? P5, which executes for what? 2 seconds, it becomes 12. So remaining, if it executes 2 seconds, remaining how much? 3. So still P5 is there, so I will place P5 in your ready queue. So next process to execute is your P1. If it is going to execute for 2 seconds, it becomes what? 14. If it executes for 2 seconds, still 2 more seconds left out. So still P1 has to execute, again I will place in your ready queue. P1 not completed, again I have placed. Next process to execute is P5 again. 2 seconds if to execute, it becomes 16. Remaining is how much here? 1. Out of 3 it becomes what? 1. Still not yet finished, so I will place again P5 in your ready queue. So P1, next process is going to execute how many seconds? 2 seconds is there. If it executes 2 seconds, it becomes 18. Done. P1 completed. So next process left out is which one here? P5. How many seconds left out? Only 1 second left out. That becomes 19. See, I have added 10 plus 1, 11, 12, 13, 14. 14 plus 5 is 19. So that much I will rub all these things. So 19, that you need to get at the end of the particular process. Hope you understood. This is your ready queue to know what is the order of execution, and this is your actual Gantt chart what you need to write. Okay, now I'll write the completion time for P1. P1, here it is there, here it is there, here it is there, here it is there, here it is there. So the right end, whatever it is there, completion time is how much here? 18 seconds. 18 seconds. P2, only here it is there, completion time is 3. And P3, only here it is there, completion time is 5. P4, here it is there, completion time is how much? 8 seconds. And P5, last is there, completion time is how much? 19. So now turnaround time, completion time is arrival time, 18 minus 0 is 18, 3 minus 0 is 3, 5 minus 3 is 2, 8 minus 5 is 3, 19 minus 10 is 9. Waiting time is turnaround time minus burst time. So 18 minus 10 is 8, 3 minus 1 is 2, 2 minus 2 is 0, 3 minus 1 is 2, 9 minus 5 is what? 4. That's it. In order to calculate your average waiting time, what happens? Waiting time here is 8 plus 2 plus 0 plus 2 plus 4 divided by total number of processes. How much here? 5. So it becomes what? 16 divided by 5. So how much I'll get? Something like 5 3s are 15. 3.32 something I'll get. Okay. So that's your average waiting time. And next is your average turnaround time. Okay. 18 plus 3 plus 2 plus 3 plus 9 divided by 5. If I add that, I'll calculate how much. Yeah, I'll get 35. That divided by 5 is 7. 7 milliseconds is your average turnaround time. So this is how your round robin scheduling algorithm will work. So hope you understood. Yeah guys, I'll solve one last complicated problem. Okay, let me do SJF preemptive. SJF preemptive. So before proceeding, what you do is you count all this burst time, what you need to get at the end of your chart. So 10, 14, 15, 21, 26, 27. So you should get 27 at the end of your chart. So let me write your chart. Okay. So you can just see here, whenever arrival time is given, the process P1 arrival time 0, whatever it is going to execute until what? Until your second arrival process time. So at 0 second, which process came first? Your P1, it is having burst time is how much? 8. So in order to execute 1 second, which process can execute is your P1. If it is going to execute 1 second, remaining is how much? 7. So your P1 will execute for 1 second. Okay. At 1 second, which process will come? Your P2 will come. At 1 second, which all process can execute is P1 and P2. So P1 and P2 can execute. P1 is having the burst time of 7 seconds and P2 is having the burst time of what? 2 seconds. In order to execute, still what? Still your next arrival time process, that is your 3 seconds. In order to execute 3 seconds, which process can execute, which is having shortest time, which is having shortest burst time? Your P2 process. In order to execute from 1 to 3, so it has to execute completely. So P2 has to execute how many seconds here? 2 seconds. That becomes what? 3. And P2 process has completed the entire time, whatever it is here. And now at third second, which all process can execute is your P1 can execute. P2 has already completed. The next process that is going to arrive into your ready queue is which one here? P3 at third second. And P1 is having what burst time? 7. And P3 is having what is the burst time is 4. So in these two things, which is having shortest time, you can just see P3 is having shortest time. It has to execute until what? Next process arrival time, that is 4 seconds. So in order to execute 4 seconds, which process can execute? Your P3. So if it is going to execute 1 second, remaining is how much here? 3. So next process to execute is which? P3. So 4 seconds has executed. So if it is going to execute for 1 second, so remaining is how many? 3 seconds. At 4th second, which process will come? P4. And which all process can execute? P1, P2, P3, P4. But already P2 is completed. At 4th second, your P1, your P3 and your P4. P1 is having 7 seconds, P3 is having 3 seconds and P4, newly added 4 seconds, is having burst time of what? 1. So in this 3, in order to execute still what? In order to execute still your 5 seconds. Which process can execute here? Which process can execute? Your P4. So only 1 second is there. So it is going to execute 1 second. Okay. So that becomes what? 5 seconds. So your again P4 also completed. P4 also completed. At 5th second, okay, which all process can execute? So P1 can execute, not completed. P3 can execute. And the next new process that enters into your ready queue is which one here? Your P5. So P1 is having how many seconds? 7. P3 is having 3 seconds. And P5 is having what is the burst time is 6. So out of these 3 things, okay, in order to execute still what? Next process arrival time, that is your 6 second. Okay, that is 1 second has to execute. Which is having shortest time in these three things? Your P3. So if it is going to execute 1 second, remaining is how much? 2 seconds. So which can execute is P3, that is going to execute until what? 6 seconds. Okay. Now in 6 seconds, okay, which all process can execute is? Okay. So now what happens is after 6 seconds, 6 seconds what happens? P6 will come. So which all process can execute is? P1 can execute for 7 seconds, P3 is having 2 seconds, P5 is having what? 6 seconds, and at 6 seconds, new process that arrives into your ready queue, arrival time 6, that is which one here? P6, it is having burst time of what? 5. Okay, so now you just see guys, okay, among this, which is having shortest time? Your P3 process is having shortest time. So again, your P3 only will execute. So complete time. So until what? Until 10 seconds. But 10 seconds it can't execute, only 2 seconds is there. So it becomes what? 8. P3 completed. So what happens is P3 will complete the task. Okay. At 8 seconds, again at 8 seconds, which all process can execute? No process will come at 8 seconds. Only remaining is these three. That is your P1, your P5, your P6. This having 7, this having 6, this having 5. In order to execute until next process arrival time is what? 10 seconds. In order to execute how many seconds? 2 seconds it has to execute, which is having shortest time, your P6. So if it is going to execute 2 seconds, remaining is how much? 3. So which is going to execute is P6 is going to execute to make what? To make your 10 seconds. Hope you are clear guys. Now at 10 seconds, which all process left out here? In previous case, P1 is left out 7 seconds, P5 is left out 6 seconds, and P6 is also there 3 seconds, and the last process you can just see P7, that is having burst time of what? 7. And whenever you reach the end of your table, and next what you will do is you go with your non-preemptive scheduling algorithm. So out of this 4, which is having shortest time here? Ultimately your P7. How many seconds is there? Only 1 second is there. So it's going to execute for 1 second. It becomes 10 plus 1 is 11. Done. Okay, next, which is having shortest time? Your P6, it is having 3 seconds. So P6 is going to execute for 3 seconds. So 11 plus 3 will become what? 14 seconds. Done. Only 2 processes left out, P5 and P1. Which is having shortest time? Your P5 will execute for how many seconds? 6 seconds. So P5 is going to execute for 6 seconds. It becomes what? 14 plus 6, 20. And the last process is which one here? P1, and it is having 7 seconds. If it is going to execute 7 seconds, it becomes what? 27. See here? It has to match the total burst time, whatever it is there. It has to match at the end. Hope you are clear with this guys. This is one of the complicated problem. Okay. So if you understand this, the other problems will be easier for solving. Now you just know how to solve your completion time. Okay, P1, where it is it? P1, here it is there, and here it is there. And whenever you want to check the completion time, towards right of your chart, whatever it is, you need to consider that. So P1 completion time is how much? 27 seconds. P2, where it is there? Only here it is there. Completion time is what? 3. P3, here it is there, here it is there, here it is there. So you have to consider what? Towards right of your chart. P3 completion time is how much? 8. Next P4, only here it is there. Completion time is how much? 5. Okay. Next your P5, you can just see here it is there. Completion time is how much? 20. Okay. Next P6, here it is there, here it is there. Towards right you have to check. So here you have to consider. So completion time is how much? 14. And P7, here it is there. Completion time is how much? 11. Okay. In order to calculate your average waiting time and turnaround time, you need what? Waiting time and turnaround time. How to calculate that? Completion time minus arrival time. Okay. P1 process, 27 minus 0 is what? 27. 3 minus 1 is 2. 8 minus 3 is 5. 5 minus 4 is 1. 20 minus 5 is 15. 14 minus 6 is 9. 11 minus 10 is 1. So this is your turnaround time. And how to calculate your waiting time? Turnaround time minus burst time. See here. 27 minus 8, you get what? 19. 2 minus 2 is 0. 5 minus 4 is 1. 1 minus 1 is 0. 15 minus 6 is 9. 9 minus 5 is 4. Again 1 minus 1 is what? 0. Guys, hope you understood this one. And just calculate your average waiting time. So that is 19 plus 0 plus 1 plus 0 plus 9 plus 4 plus 0 divide by total number of processes how much? 7. So whatever you get, that many milliseconds is your average turnaround time. And average turnaround time, so waiting time, average turnaround time here it is there. So 27 plus 2 plus 5 plus 1 plus 15 plus 9 plus 1 divide by total number of processes how much? 7. Whatever you get, that many milliseconds. That is your average turnaround time. Guys, hope you understood with this one. Okay, just make a note of this. Okay, thank you.